Hi everyone, welcome to our talk. So the next 35 to 40 minutes, we are going to talk about how you can compose your next app. And before I jump into the agenda, let me do a formal introduction. So Himanshu, can you change the slide? So yeah, my name is Niharika Arora, and I am a Google Dev expert for Android. I am an open source developer, and recently I have contributed to India's contact tracing app Arogya Setu. I am a speaker, blogger, and a mentor, and currently working as a senior Android engineer at 1MG. So with me is my co-speaker Himanshu. I would like to call him to introduce himself.
Hey everyone, I'm Himanshu. I'm a Google developer expert in Android. I've been into open source contributions for the last couple of years. I've been a speaker and currently I serve as a senior Android engineer at Rumi.
Thank you, Himanshu. So now, without any delay, let's just come to the agenda for the talk. So, firstly, we need to understand what Jetpack Compose is, like why and how Jetpack Compose comes into the picture, like getting a basic understanding around it and what exactly it does. Then we will talk about how it works under the hood, like talking about how Android guys have implemented it, and as I believe one must be curious about knowing how things are implemented internally so that you will be confident about the stuff you are working on. Then we will see how we can compose different UI widgets like normal text views, buttons, recycle views, etc. Then last but not the least, we'll see how we can integrate other Jetpack components with Compose and many more. So this talk is based on Jetpack Compose Alpha 07. But before we jump into the definition for Compose, let's first understand why it came in picture. So an application is all about logic and UI, right? You have to create many elements. Like let's say you have to design a login screen. You may need a view group like linear layout, then text views, then button, and doing some logic stuff. And for all this, you must have a class. Then creating the whole UI in your XMLs, then the layouts can be complicated and can be dynamic. Like you have to show some views based on some logic, and you have to hide them as well. Then you may have to set some style and other attributes there. So then comes the Kotlin files where we have to bind everything. And earlier we were using file view by ID, and now we have this data binding or view binding, right? But yes, too much of code. And other aspects, we talk about separation of concerns. It's like grouping much related codes as much as possible, and dependencies should be less. So now our code is written in Java or Kotlin, and our UI is written in XML. Even though both are written in different languages, still they hold the reference and they are tightly coupled. And each and everything that eventually has to work like one component, this has been segregated and then across many different files, right? So now looking at the first glance, we won't be able to get the whole context of what is going on, and we have to check each and every file there. So is there any way that we can do it in much better approach, like just with a more clear context, and yes, of course, less code. Also, can we structure everything like Flutter in just one language, and that is just by means of code. So as now we may have just one language, so we can increase the cohesion there. And here I don't mean mixing the logic with UI. So just keep in mind, and I will explain that how we have maintained this even with Compose itself, the separation of concerns. So now coming back to the idea, I like one explanation from Google I/O, which says that let's say we have a very basic example here, a basic text. In our main function, we have written a print line, which basically prints the basic text, right? And this is in Kotlin. So can we leverage the same way of writing a whole Android app like this? So like I just let's say I have just have to show the text I have in print line. I just can I just call this like this? I have a text widget, and I am just adding it to UI hierarchy, and the text is getting printed the same way. So can we? Why don't we have why don't we move to a kind of declarative UI where we just tell what needs to be done rather than how specifying how it is getting done? Like in Kotlin, we have some operators like filter or map, right? So with same idea, Google in 2019 came up with Jetpack Compose this as a UI toolkit. So now it is giving us a single source of language paradigm, and it's in our favorite Kotlin. So and it's fully compatible with other existing view system. And trust me, when you look at the views like button code, which earlier had 10 or 12,000 lines of code, it has now reduced to just 10 to 12 lines. Can you believe that? And as also earlier, our button class was extending text views. I don't know why it was like that there. It was like this. As we don't want our buttons to be selectable, right? And we don't want them to be changed. And so with Compose, all these things have been updated. And that's a huge difference. Now, we have already talked about the idea. Now, going with the definition. So, Jetpack Compose is a new UI toolkit for Android. It's a kind of newer design set provided by Google, which is basically not bundled with our platform releases. It can be available to us immediately, and one can admit we have this issue with our present UI system. If any bug comes up in our view.java file, we have to wait for a new version to come up, but thankfully, with Compose, we have a solution now. And as we already discussed, the declarative UI thing. So with one language, now we can use one language for everything, and our XML has been moved entirely to Kotlin, and so yeah. And yes, as we know Kotlin, so things are pretty much easy to learn, adapt, and explore. Himanshu, can you move it? Yeah. So now let's see very basic example. Don't worry, I will be explaining what is happening here, and it is very important to understand this for the upcoming concept. So we are writing functions for a long time, right? And just to separate concerns elsewhere in our code. Now, anything you write here inside the method, that will be displayed on our UI screen. But right now we don't know how is it getting done, how we just wrote something in a function and that is getting rendered as a UI. So what is the magic here? You must be seeing this composable return above our function, and so this is the real magic. Let me show you a normal text to render. If you write like this, you have a text widget and you're writing hello world inside it, and you can see the output on the right side. Hello world is getting displayed, right? Now, we understand that composable is doing some magic to render it as a UI widget. But how does it render in the real world? How to add it in our UI hierarchy? Let's talk about that now. So do you remember this set content view? When we set the layout, when we have to inflate any layout. So, but with now with Compose, now you just need this set content method, and it requires a composable inside it. Like here, you can see the material theme. It is also a composable function, and I have passed the same hello world print line there, the same function where hello world was getting displayed. So this is again a composable. This is a very basic UI, like how we set in an activity. Now let's see how to do the same in fragments. So if you remember, we return a view from our on create view method. Now with Compose, you just need to return a Compose view, passing the context, and just set the context the same way we did for the activity. So everything you have to render here with Compose on as a UI on our screen. So that everything will come under this set content method. But wait, we talked about the rendering part, how set content can be used, but did we really talk about this composable? We saw return of the function. What is it exactly doing, or how does it helps us in rendering? I think no. So let's understand what is this composable annotation. As a dev, you must have encountered this term annotation. It is nothing, it's just a metadata or a set of data which basically gives information about another data, or I can say it will tell you how the function needs to behave. So now this composable function is a tool is that tool which I was talking about in the beginning, which when we discussed how we can still hold the separation of concerns with Compose. So it's a function again, and we know that we use functions for separation of concerns. So it still holds the separation of concerns, and that too in much better way. So everything which is UI related need to have this annotation, as this function tells us what is going to render or populate as a UI widget on the screen. And one important thing to note here is, so there is no actual annotation processing getting done here. So this annotation just signifies that this is a UI function, and also it has its own runtime, that is composed runtime. This knows nothing about Android or UI. It just knows there's a tree or UI hierarchy, and then it processes everything which is written there as a composable function. Whenever we write anything to render and we don't provide any styles or attributes or any specific position to a UI widget, so the Compose runtime starts rendering that UI widget, taking these 0 by 0 XY coordinates as a starting position. Now let's see how we can compose different views, and that too in an easy manner. So we all have worked with layouts like view groups, the linear layout, relative or constraint layouts, right? Now let's take linear layout example. We have linear layout with vertical orientation, and maybe you have to set some views inside it. If you go with XML, you have to write a bunch of code with there. But with Compose, this all can be done in just few lines of code, and as you can see there. But now here I have introduced a new term. Android has introduced a new term, that is column. So that will play this role of setting the orientation as vertical for our UI components like this, and you can see how it works on the. It looks like on the screen itself, and we can use row if we want something to be in horizontal orientation. Now, let's see how we can render a text field, or I can say an edit text. You can just set any color, text style, containing the font size, border, or shape, anything. But don't get confused. I know it's overwhelming. I will be explaining these. But before that, this is how it looks on the screen. This is how our edit text is getting rendered. But now, what this email state is, why is it written this way, or why do we even need it? As here comes a new term, that is state. So state is a value at an existing time. So with Compose, whenever we render anything, it gets rendered with initial value. Here for our edit text, it was initially blank. So even if you type something through keyboard, you won't be able to see anything in your edit text. And the reason is, your Compose runtime doesn't know the changes you have done, as it is not recomposing the concerned UI widget, so the changes won't be reflected. If I talk about XML, with XML that is easy. Like whenever you have this get text or toString for any edit text or text view, we get the latest value. With Compose, when the screen was rendered, it had an empty value. Now everything is a UI function as how it should look. So we need to recompose whenever there's a change happening with the value. So it's like a text watcher in an edit text. And if there is no concept of state, every time you do this get text or toString, you will find the initial value there. So that's why the state has been introduced, that whenever that value changes, it finds the place where it has been used and it recomposes that view to reflect those changes. Now you can see that the flattened hierarchy, which was helping us in performance improvement with constraint layout, we have this here as well, right? Like now the affected UI widget is the one which is getting recomposed only. Now, as we see this state, we have added this remember keyword as well, right? So as the name suggests, it remembers something. And here it remembers the latest value it possesses. And this value computed by remember, this is stored in a composable function memory. And every composition we have, they have their own function memory for them, which holds a particular state at an existing time. Then at any point of time, any changes are occurring. So whenever there is a change in some value, so at that time, that view is getting recomposed. Now, Yeah. So now, whenever so here you can see. So one thing with the remember is as soon as you remove any composable from the composition, so it forgets the object like it never existed. So we don't have to do anything there. As now here like this, we have set the value of state after reading from the state, and this is how our we are updating the value of a state whenever there is any change happening in the text field. So we are updating like this, and every widget which is consuming the state value here, that is our text field, we can see. So this will be getting recomposed to show the latest updated value. So this is all about how we can persist or update the latest value in the UI widgets. Now we have another term, that is modifier. uh, so now with every design of widget, we need to add some attributes or give it some style or padding. So this property modifier helps us out there. So modifier is like CSS, which we can use to beautify our views or how the component is displayed on the screen itself. You can set the width, height, background color, anything you can do for styling, you can do with modifiers, and you can also add clickables with proper logic. So remember one thing: modifiers work in a sequential order. Let's say you have to give a background color to the whole screen, and then you need to apply a padding of 16 dp to your container. So what will you do is you will be adding a background color to your modifier, and so that it takes the whole screen, and then in sequential manner you will be applying the padding to the container. And if by mistake you reverse the order, so there will be a outer layer of padding, the space will be there, and the remaining space will be the remaining space of the container will have the background color. So I think you can imagine that. Now here we saw why and how Jetpack Compose come into existence, what problem is it solving, or how you can compose different views, put styles, attributes, or and one important aspect, that was our state, which is how our values are getting updated. Now I'm handing it over to Himanshu, where he will be explaining how things are getting done under the hood, how you can integrate Compose with other Jetpack components. So yeah, over to you, Himanshu.
Thank you, Niharika. So if I have to start right now, I have to start off with architectural components. So if you know right now, right, when we design an app, there's a very high possibility that we are using view models. We are using a lot of different aspects there of architectural components. And what view model actually does right now is it holds the value and passes on the UI, right? So in Jetpack Compose, let's say I'm going to understand we have to design a data-driven UI. A data comes from the server and it gets set to this user model. So the user model, I've already created a mutable live data and a live data here, which would be in the view model, and this would be stored, the value would be stored here. So this is where it is going to be stored. Now, let's say if I have to design that profile UI composable, right? So I have declared it as a function, as Niharika said, that composable is already a function. So we have passed on a main view model here as a parameter, right? Now, if we are passing this parameter view model, we have initialized it in our fragment. And when we have to set this profile UI composable, we return the composed view, just how everything has to happen in fragment, right? And when we have passed the view model, as a next step, what you need to do is you always try to observe that specific live data, correct? But in this case, in composables, you actually don't observe it or you don't do any other stuff like that. So rather than that, what we do in composable function is that we convert that specific live data as a state. So basically, observe as state is an extension function for a live data, which is provided by Jetpack Compose. So now this live data has been converted as a state, and it is converted to just give us the value. So we don't have to observe it again and again in a composable. Now, now let's say that we have to design that UI based on the user value, the user state which we had, right? So we can't directly use that state. So now if I have to design a UI, let's say name, email, details, or any other stuff, right? So just to get that value, we'll use that state dot value. So that's how we get that value of a user, that user object, which is coming from the server. And that's pretty much it. Now, whatever you want to do it, you can just design the UI based on the user value which we received. So this is how also you can design a lot of different UIs based on certain data which comes from the server or a certain dynamic data which is coming up. So this is very much useful when you are designing a dynamic layout, and this this is basically how everything gets managed in a Jetpack composable. So everything here basically works as a state which holds a value. So here user was a value, so it created a state for that, and then it returned its value. So that's how basically a value storation works in Jetpack Compose. Now, when we talk about a lot of things, one aspect which fascinates a lot of devs is how it actually works under the hood. Like, what is that new aspect which we are doing? So, if you remember that function, say hi, which we have done, right? So, this was how it was getting rendered in that UI part, right? But we don't know how it works. We're just creating another Kotlin function. We are passing on a text and it gets rendered, correct? So, now we need to see this under the hood, right? That composable function itself. So if you know, when we do a lot of different fancy stuff in Kotlin, let's say we create a suspension function in core routines, that also technically looks like just another function in Kotlin. But when we decompile it and when we see its JVM bytecode, then you see it works as a normal function, but just passing on that suspend keyword, it gives us an extension continuation callback, right? Similarly, when we decompile the composable function, this one, the say hi function, this looks pretty much similar how the decompiled version of say hi would look like. So now when we decompile it, you can see the say hi now has a composer and it has a value. Then it starts here. Then for another composable, which is the text here, it again has a composer there. Then it has a specific value, and then the composer ends, right? So basically, if you see, we have a reference of composer here, but what exactly is this, right? So basically, the say hi function on the left hand side is basically pretty easy if you have to consider in that way, that this looks much readable. But this thing is a bit confusing, like what composer is actually there and what that value plays as a role. So let's see in a very basic term. So I would rather help you with composer is like a table, right? In which this value, which we have, is like a key which specifically maps to a composer. So right now, if you see here in the say hi function, right, we have two different composables. Say hi itself is a composable, right? And the text is also a composable provided by Android. So now we have two composables, one given by Android and one created by me. So now what this composer does is this composer creates a container. So when I say a container, don't think it as a Docker or something. It's just a collection of things. So this composer, what it does, it gets passed on to that specific composable. Now, what it does, it starts the value. So the value which we had here, that is 500. So what it does is, when we do a start, it basically says, okay, now let's start rendering the other composables which we have. Then as a next step, we pass the reference to the next composable. There you go, like how we did in the text. But here you can see we have a different set of values, right? And when this composable runs, we just end that composer. So in a very shorter way, what it did was it first decompiled it, passed on a composer and a value. Then it started the composer with that specific value. Then it started rendering all the composables which we have. So here it was text. Consider if we had any other composable which was created by us and not provided by Google itself, at that same point as well, it would have created another composer. Inside that as well, it would have gone, it would have started the value, and after the renderation of the second child composer, it would have ended itself, and then it would have ended the parent composer, right? How we have done here, right? Now, in a very UI side, like where you can basically specify or visualize how things are working. So check this out. This is basically that hash table, but this was not actually a hash table. This was another data structure called gap buffer. And inside this, we stored, so if you see, we had two different values, right? 500, then we had actually 400, right? So we had basically two different composables, say hi and text. So I have just mapped it out here as a very crude value of 500 and 400. So that 500 is basically that say hi composable. The text is stored in the second slot, and that's how it gets stored there. So this basically the whole gap buffer thing itself, it's a composer, and each of them contains a value or a composable. So that's how it gets there. And when the UI renderation happens on the screen, the whole gap buffer actually renders on your profile, on your screen, on the phone screen, and that is when a user actually sees that. So that's pretty much a very basic idea how composable works. And just to give you a very generic overview how we have been doing certain things right now, how we can do in uh, let's say in Jetpack Compose, that's the second part of this talk, which where we are going to actually compare how we did something in an XML file and how we have to actually do it in Jetpack Compose, right? So let's see this. We have a text view initially. This is how we used to do in XML of an activity, or let's say of a fragment. So we first declared an ID, then we had to specify a size and height, like width and height wrap content. We used to pass a certain value, hello world, text color, text size, right? So that's how we used to do right now. But if you have to do the same thing in composable, right? How would you do it? So the other example on the right hand side is of print hello world function. We created that, just another function in Kotlin, but we annotated that as a composable. Now this composable annotation helps us to tell that this is a composable function which would help us render that UI. Inside that, we just created an object of text, which is a UI component provided by Compose. We passed on a default value of hello world. We wanted a text color, right? In the left hand side, we had Android text color is white. So we passed on a color white here. Then we passed on the size. So if you see the difference here, on the left hand side, we had a text size of 50 SP, right? But here we have a font size of 50.sp. So that's a difference how you do in Compose. But just to see, this looks more cleaner and it looks very much sleek, right? Rather than comparing it with what XML used to do for us. Now, coming back to one of the most commonly used thing in our Android apps. So almost all Android apps has recycler views. It is one of the most commonly used widgets of Android, right? So when we design, let's say a recycler view, what we do is first we design an XML file, right? Then we have an adapter. For that specific adapter, we have a view holder. And to accommodate all of these, we have a fragment or we have an activity here. So roughly we have around four different files, if I have to say in that way. We can do it in a single file as well, adapter and view holder. But right now I'm saying we have four different files, an activity adapter, view holder, and item XML. So that's a tedious way to do it. A four file just to declare a list. And Kotlin, oh sorry, in Jetpack Compose, we have something called lazy column for. So what it does is it actually works like recycler view, and it has a lot of like we have to pass the source of data, which has to be a list. So it can come from, let's say, what do you say that a view model, we can pass a very rough value or a very hard coded value of list, and inside that we can design our UI. So now here the UI can be done in a lot of different ways. If you want to do it, you can do it here as a nested UI. You can also do it in a whole different UI set as well and just add that code or import that code here, right? So that's how you can do. So that's pretty much for this talk. Like now, just let me add some reviews or some findings which I have seen on my end while working with Compose. So when working with Compose, I definitely feel this is like the next step ahead for us to build UIs in Android, because that pretty much gives us a lot of flexibility that anything and everything can be handled via recycler, Kotlin. Now, second aspect, with Compose, we are getting technically a lot of different things coming up. We have pagination coming up here. which we can use to do pagination list designs. We have its own navigation composable, which is like navigation components, and it's specifically done for uh, Jetpack Compose. So basically, that's not production ready yet. Everything is in alpha, but how things are building up for Jetpack Compose, it's actually nice. So if you want to explore, if you want to see more about Jetpack Compose, one of the best resources I found out was the developer documentation. Definitely, yes. I have added another link, which I had created as a side project. This basic side project had all the latest resources of data store and, let's say, Dagger Hilt, and this all has to work. The UI component used to work with Jetpack Compose. It has the pagination, navigation components, everything. But for Jetpack Compose, apart from this, one of the best resources you would see on GitHub on online is by Vinay Gaba. That's basically like a roadmap how you can learn and learn via examples by doing. So definitely check this out, guys. And if you are actually interested in exploring Jetpack Compose, the repository by Vinay is definitely the one to look out for. Thank you, guys. That's all from us. So, if I'm not wrong, there's a question called how do you define constraints for compose items? So, if I can interpret this question, constraint for a compose item means adding constraint to a constraint layout for a composable, right? So, you can actually, we actually have a constraint layout mapper for a composable itself where you can add different types of constraints there. So that is how you can add constraint and design UIs based on certain constraints, if that's what you were looking for as a question.
So for the next question is how do you test Compose app? So for testing any Compose, we have different dependencies available. Other like the you have the espresso, so you can test that.
Right. The second question is how do you specify height and width? So as Niharika mentioned in the talk, right, there is something called modifiers in Compose. So using modifiers, you can set width, you can set a match parent like fill max width, or let's say if you want to have wrap content, you just exclude any of that. So that's how you can specify height, width, or any other different properties of UI if you want to.
Yeah. Are there any major changes in alpha? Should I wait till beta or RC? So, with our opinion, we can say that for production code or anything you are working with a million user base, with alpha, you shouldn't move to the production based code. And for small projects, you can do that. And as with alpha, we know that there are many structural changes are also happening. So I think you should wait for beta or RC for your production one.
Definitely, and adding onto this, alphas are just for experimentation, or if any bug comes up, just report it to the Google community. But if you have to go to production, it should be at least in beta, or what I feel is it should be at least stable enough so that user doesn't get impacted. So the next question is comparing single element doesn't give an overall picture of the difference. Can you compare an entire layout? So we don't have the time right now to compare an entire layout, but definitely yes, if the links which I have shared have a lot of different components and layouts which we have designed. So do check that out.
Next is how do you support multiple devices in Compose, like example, mobile or tablet devices? So yeah, so there are some changes like when you were using XMLs, you have to create many layouts depending on your density or the orientation and everything. So with Compose, you're just writing like you are doing with you are doing with JavaScript or HTML. So it will be rendered the same way depending on the screen size itself. So you don't have to worry about that if that is what is you are asking for.
Right. The next question is, do you think devs will still use the old way designing with XML file as always? So this question is still debatable. I would say when ViewModel came into the picture, everyone was like, we can still use presenters and we don't actually need ViewModel, because frankly, everything solves an existing problem we had in our UI kit, right? So now, since everybody's a fan of Kotlin, everybody starts uh, like knows Kotlin in and out. So if you have to design it, why not design it with Compose, right? So now in a certain way, you don't have to manage two different codes of Kotlin and an XML. Do everything via code and make it more dynamic, right? So it can be done in XML, it can be done in Compose, but there's no harm in exploring other stuff.
Yeah, next is with Compose, there is a possibility that mess up logic and UI implementation. Do you have any suggestion to separate the implementation, which also getting benefit of Compose? So yeah, as we told you in the slides itself, that separation of concern is still there. Composable are just function. We are having composable functions, and you can write it. Even you can have different. You can write your composable in different files to make your code more readable and understandable. Also, as the functions holds those separation of concerns, same way you can have small composables for writing, like you have a button, text views. You can write different composables for everything. So yeah, you can still hold this separation of concerns.
Right, and adding on to Niharika's suggestion, like right now, what we used to do is, if let's say we had a custom design or custom background, right? We used to do a custom view design, and we used to have a common UI, and then we used to just call it in our XML, right? Just to have that common theme across. So in composable as well, let's say you have a user which you have to call in a circular layout. You just create a very generic function, like how we do in functions, right? We create a function, you just pass on a parameter, and based on parameter the image gets loaded. So you just create it in a separate way, let's say images.kt, because that's something you'd load as an image, and wherever you need that design or that theme or that UI layout, you just call that function. It's just like similar to how we call functions in Kotlin. Now the next question is styling theming easier with Compose? Definitely yes. It's a definite yes. It's a very cool way to do it. I would say in that way that you can dynamically change themes and all of different stuff. You can render even the path or SVG images as well in a very fancy way. So it's a very easy way to do it in Compose.
Yeah, and even adding any styles or composable. Earlier, what you have to do is you have to do it for like the night theme and the normal. You were having different styles based on your night or dark light theme, so you can handle that easily here. Now we have, how do you find going from layout editor to code? Biggest benefit of XML is the design to drag and drop elements. Compose seem a step backwards. So with Compose now, with latest Android Studio, we have this preview thing available. I know that drag and drop is easy, but what I feel is I haven't done it. I haven't done this drag and drop in my whole career. And even if you drag and drop anything, you have to adjust it based on your based on the constraints you need. You have to give a margin, a padding, and then you have to set it above or below anything. So I would say maybe it's my perception, but yes. I think with preview, as you can see that, and it's just that you have to just write very few line of code. So I won't think that And even with Compose, things are changing, so maybe you will get some options like that. But yes,
Now, the next question is what performance differences of XML rendering and declarative UI code Compose actually does, right? So, traditionally seeing there's not much performance issues. It's still in alpha, so we can't predict on that performance issues. But one thing for sure, it actually increases the efficiency of a developer. I would have to say that because I personally don't like doing XML stuff again and again. So, it increases the performance for me as a dev. On a UI renderation, it's still early days to compare between both of them. But yes, initial go ahead for me has been good and for other devs as well.
Okay. So can we build cross-platform applications with Jetpack Compose? Yes. We have Kotlin multi-platform, and that is Jetpack Compose can work with that. So yeah, you can try that as well.
So adding on to the answer for Subhi, it's basically like just having the data source. The UI has to be designed on Jetpack Compose, right? So Compose would just help you render the UI for the user. But the data source has to come from somewhere. So let's say if in Kotlin multi-platform, you just pass on that data source, and at that point, you come up and just design the UI. So the next question is, what is the future of data binding with Compose coming over? A lot of different features are actually coming up. This is something I'm not aware of, like if data mining with Compose is coming up, but I'm definitely sure that Google might be working onto it, because if this is like the next V2 UI toolkit for Android, data binding is one of the major aspects of Jetpack Compose or the UI building, right? When we used to do so, maybe yes, it should come over in coming days, but I'm not pretty sure right now.
We have so we have does data binding support incremental binding? I am not sure about it. Himanshu, can you do you have something to say for this?
I am also not sure about. I think it does. I'm not sure. I can't comment on this one
Yeah, but I think
specifically.
new things coming up, they support this. I won't see this as a backward thing that if something was there and it is not existing right now. So I think it should support, but yeah, we are not sure about it. I think we were able to answer your question. So thank you guys. Thank you for having us here.
Okay, so we have another question. The question is, do we need fragment with Compose? It actually still a question how you want to use it. So there is, as I would say, there is no proper architecture defined right now for how to use Jetpack Compose. So my personal favorite has been the single activity multiple fragment approach, what I have been doing till now. What I do is I have been doing how I have been doing right now for all other apps, but in place of doing with XML design, I design the UI with Compose. If you don't want to do it, what you can do is you can have a single activity and a single fragment, but there you just inflate that fragment in the activity, and whatever rest designs you need to do, correct, you can just do it in the fragment itself. And to navigate between multiple different composables, you can use navigation component, yes. But if you don't want to use fragment, it's still fine, you can just do everything in the activity itself. So it's just how you want to use it. Thank you so much, everyone, for joining in, tuning in, and asking amazing questions. So I hope we were able to answer all your queries. And if you have any other queries which you want to ask, head back to our Twitter account and just you can ask there. That's all. Thank you, everyone.
Thank you, guys.